Types of sets. Hello everyone, my name is Christio Manawan, and my student identification number is 2510110601000. Today I am going to explain an important topic in mathematics, which is sets and logic, focusing on the different types of sets. Sets are one of the most basic and essential concepts in mathematics and logic. A set can be described as a well-defined collection of objects, which are called elements or members of the set. These elements can be numbers, letters, people, or even ideas. Anything that can be clearly identified and grouped together. The concept of sets allows us to organize data, describe relationships, and make logical connections between different groups of information. For example, in computer science and information systems, sets are used to represent databases, filters, and logical groupings. Now let's go through the different types of sets that you can find in mathematics. First, let's talk about the finite set. A finite set is a set that contains a limited number of elements. This means that if you start counting its elements, you will eventually reach the end. For instance, suppose we have a set A that contains the numbers 1, 2, 3. In this case, there are only 3 elements. Since we can count them completely, we call A a finite set. Finite sets are very common in everyday life. For example, the number of students in a classroom, the days of the week, or the number of months in a year are all finite sets because they have an exact and countable number of elements. Next, we have the infinite set. An infinite set is the opposite of a finite set. It contains an unlimited number of elements, meaning the list goes on forever and never ends. For example, if we define set B as 1, 2, 3, 4, 5, and so on, we can see that it continues infinitely. We can never reach the last number because numbers go on forever. Therefore, B is an infinite set. Another example of an infinite set is the set of all natural numbers or the set of all even numbers. These sets cannot be completely counted because they never stop increasing. Infinite sets are very important in higher mathematics, especially in calculus, where they are used to describe continuous processes or sequences that approach infinity. Third, let's discuss the empty set, also called the null set. This is a very special type of set because it contains no elements at all. It is written as an empty pair of curly brackets, like this, or sometimes with the Greek letter phi, written as O. For example, if we want to create a set of all students in a class who can fly, that set would be empty because no human can fly. Therefore, it has 0 elements. The empty set is important because it acts as a foundation for other set operations. It also helps in defining the idea of nothing in logical and mathematical expressions. Fourth, we have the subset. A subset is a set where every element of one set is also found in another set. This means that if all the elements of set D are contained within set A, then D is a subset of A. For example, if D equals 1, 2, and A equals 1, 2, 3, we can see that every element of D is also present in A. Therefore, D is a subset of A. Subsets are very important when we analyze relationships between groups. In computer science, for example, subsets are used to represent smaller categories or filters within a larger dataset. There is also a special type of subset called a proper subset, which means that the smaller set is part of the larger set but not equal to it. Finally, we have the universal set. The universal set, usually written as the letter U, is the set that contains all possible elements under consideration in a particular discussion. For example, if we are studying numbers from 1 to 5, then the universal set can be written as U equals 1, 2, 3, 4, 5, 5. Any other set that we talk about, like A or B, must contain elements from this universal set. The universal set gives us a boundary, helping us understand what belongs inside our discussion and what does not. It is very useful in Venn diagrams and logical reasoning, where we visualize relationships between sets using circles or regions. To summarize everything, there are 5 main types of sets that we have discussed today: finite set, infinite set, empty set, subset, and universal set. Each one has its own role in mathematics and logic. Finite sets are countable, infinite sets go on forever, empty sets have no elements, subsets represent inclusion, and the universal set includes everything in the context of discussion. Understanding these types of sets helps us build the foundation for more advanced topics, such as set operations, relations, and logical propositions. In the next lesson, we will explore how sets interact with one another through union, intersection, difference, and complement. These operations are the key to understanding how logic and mathematics connect to real-world data systems. Thanks for watching.